Hello Crypto Gang, welcome to another LamboLife video. Zcash is one of the best privacy coins in the world. Although its privacy is not on par with Monero's level, it is also more scalable than Monero is, at least for today where Monero is focusing on privacy first. But I'm not here to compare the two. After all, the technology behind Zcash is very different. You may have heard of the so-called ZK-snarks. We'll talk about that in a moment. Zcash privacy is optional. That is to say, you can opt to be transparent on all your transactions. Even if you opted to use a shielded address, you have the ability to disclose it publicly by deshielding it. You can also choose to disclose it only to a special person or entity in case you want to audit your business but don't want to reveal your transactions publicly. We'll also be talking about how Zcash maintains the integrity of the system, that is to say, how it makes it impossible to create Zcash from thin air. We don't want fraud, alright? Let's begin. There's two types of addresses in the Zcash protocol: transparent addresses denoted as T addresses and shielded addresses denoted as Z addresses. T addresses always start with a T while Z addresses always start with a Z. T addresses are public. During a transaction, all transparent addresses interact with what is known as the TVP or transparent value pool. The TVP is what publicly reveals transaction data, allowing it to be viewed on the Zcash blockchain by anyone. Z addresses, or shielded addresses, are private and more secure. It hides your identity, the amount in the transaction, and as such, verifying its validity requires the generation of the so-called ZK-snarks. Essentially, ZK-snarks allow you to prove the validity of your transaction without having to reveal any information of that transaction. I will tell you how it does this in a moment, so be sure to finish till the end. By the way, if this is your first time in this channel, be sure to subscribe to be updated with my crypto research. I post videos regularly. So now you know the two types of addresses in Zcash. But you might be thinking, what happens when a T address sends payment to a Z address, or vice versa? Will the transaction be private or not? Let's explore four possible scenarios here. When a T address sends to another T address, obviously it's public since both addresses are transparent. When a T address sends to a Z address, then it's shielded, meaning the amount of the transaction is hidden. When a Z address sends to a T address, then it is deshielded, meaning the amount of the transaction is revealed. And lastly, if a Z address sends to another Z address, then it stays private. So those are the four possible scenarios and their outcome. But just know, this doesn't apply to complex transactions such as when both shielded and transparent addresses are sending and receiving payments back and forth. In that case, privacy will be compromised. But what if you want to disclose your transaction data to a single person or group only? That's where viewing keys feature comes in. Essentially, it allows encrypted contents of shielded transactions to be disclosed selectively from a specific transfer. Furthermore, viewing keys may be provided to disclose all transactions for a given shielded address. So let's recap. There's two types of address: transparent and shielded. Transparent addresses are placed in the transparent value pool where they can be viewed publicly. Shielded addresses are encrypted or hidden. Since this is what gives Zcash its strong privacy feature, verifying this data without compromising it would require the ZK-snarks technology to be coded on the Zcash blockchain. Let's talk about that. ZK-snark stands for Zero Knowledge Succinct Non-Interactive Argument of Knowledge. It refers to a proof construction where one can prove possession of certain information for example, a secret key, without revealing that information. Essentially, zero-knowledge proofs allow one party, the prover, to prove to another party, the verifier, that a statement is true without revealing any information beyond the validity of the statement itself. Don't be confused by prover and verifier here. There are no humans manually verifying. This is all done automatically on the Zcash blockchain. Now, generating this type of proof is quite complicated. It relies on a set of public parameters, which allow users to create and verify private transactions. As of now, the most efficient known way to produce this type of zero-knowledge proof is to have an initial setup phase, where some random numbers are sampled, which are then used to construct the parameters. The sampled random numbers is called toxic waste, and it must be destroyed after the setup phase in order to prevent any double spending and preserve the integrity of the Zcash blockchain. In order to ensure the toxic waste does not come into existence, the Zcash team designed multi-party computation protocols that allow multiple independent parties to jointly construct the public parameters. Zcash has created two different sets of public parameters so far. The first ceremony was generated in October 2016, and the second happened in 2018. I hope you've been able to follow so far. Tell me if it's not simplified enough in the comments below. The Zcash mining algorithm is called Equihash, an asymmetric memory-based variation of Bitcoin's proof of work. It technically is still proof-of-work system. It is asymmetric in the sense that a verifier does not use the same amount of memory as the prover in order to validate a proof. Zcash is designed in such a way that proofs that are computed are difficult to prove but easy to verify. Equihash is memory hard. That is to say that the amount of proof-of-work mining that can be done is largely determined by how much memory or RAM your device possesses. Equihash cryptocurrencies like Zcash used to pride themselves for being ASIC resistant, until Bitmain effed them over and created Antminer Z9, a specialized hardware that allows its users to mine coins more efficiently than those that don't use any ASIC, and thus create mining centralization in theory. Unfortunately, Zcash decided not to focus on being ASIC resistant for now. That's it for part 1 of Zcash, but don't worry, this isn't the end. In part 2, I will be discussing how Zcash plans to scale. As you all know, scalability is very important. If you want a cryptocurrency to become popular or increase in value, it needs to scale, to level up, to be able to handle more users, and that's what I'm going to discuss next. So be sure to hit that bell notification in order to see it as soon as it's uploaded. Also, like any other cryptocurrency, I'm always opting to show the drawbacks, and it won't be different for Zcash. I believe that no matter how much you care about a particular coin, you should see it for what it is and not be too caught up in your own overzealousness. I'm here to help you, not to kiss your bum. Thanks for watching. See you on the flip side.